Hello, this is section 1.5, and in this section we're going to analyze functions and we're going to analyze the graphs of functions. And so our objectives are to use the vertical line test, and that's a way to see if a graph represents a function. We want to algebraically find the zeros of the functions. We want to use the graph of a function to determine the intervals on where it's increasing or decreasing and where its relative maximum and minimum are, and we'll go over all that. Algebraically determine the average rate of change of a function between 2 points, and algebraically identify both even and odd functions. Okay. So the next slide is just going to be a graph of a function, and this is just, I'm just including this just to remind you, the key right here is that if I look at this point right here, xy, just a random point, y is equal to what you get when you plug in x into the function. So I take this x and plug it into the function, and that gives me y. Okay. So here's an example of a problem. Given the graph below, find the domain, the function values at x equal minus 1 and x equal 2 in the range. And just a couple of things here. Right here, notice the circle and open dot. That means the point isn't on the graph. And conversely, over here, notice we have a closed point. That means it is on the graph. So a closed circle, so a filled in circle. That means the point is on the graph. So again, right there. Okay. So again, I'm going to let you work on this. I'm going to hit pause in a second and then go to the next slide. Okay, so hit pause. I'm going to go to the next slide. Okay, so hopefully you've worked on this and figured out the answer, but I'll go over it. So again, the domain is all the possible x values. So we start, that's the first one, and then x equal 5. It goes up to x equal 5, but not including x equal 5. So our domain is the interval including minus 1, but not including 5. Remember that this means not included, the parenthesis. Okay, now we want to find f of 1 and f of 2. So remember right here that if we go to the graph, this is going to be the y-coordinate. Y is f of minus 1, and the y-coordinate is 1, so that's the answer there. And then down here, this tells us, let's move it over more. So we get this f of 2 is going to be minus 3. In other words, we plug 2 in, and then we get 3, and then that's the y-coordinate. So we have the answer to that over here, and then we want to find what the range is, and it goes from y equal 3 to y equals negative 3. So this goes from y equals minus 3 to y equal 3 inclusive. So y is, so that's why we get this answer here. And these are y values. Since it's the range, these are y values. Just like over here, since it's the domain, these are x values. Okay, so on to the next one. Okay, so the vertical line test, it's really simple. You have a graph and you imagine drawing every possible vertical line. through the graph. And if every vertical line just hits the graph once, you have a function. So this passes the vertical line test. And over here, this tells us right here, notice the vertical line hits twice. So that means it's going to flunk the vertical line test. And when you hand problems like this in or do them, I think it's good to make notes like this. Now, why does this work? That's what I'm asking over here. Why does this work? Think about it and go to the next slide. So here we are right here. Okay. Remember, a function can have at most one value corresponding to a y value. So if the vertical line hits the graph twice, that means this x has two y values. Okay. Now over here, notice that any line hits the graph once, so that means any vertical line hits the graph once. That means that there's no x that has two y values. So I'll indicate that here. So that's why it works. So the vertical line identifies y values. So, and again, these are good explanations. The reason I'm writing it is just I think it helps reinforce the concepts. Okay, so that's a handy thing to know. Okay. Okay, so we want to find the zeros of a function, and finding the zeros is just solving the function equal to 0. So that's the same as finding x-intercepts. So we want to find the zeros to the following three functions, and here's how you do it. So again, solve on your own, and then go to the next slide. So hit pause. I'm going to go to the next slide. Okay. So find the zeros for A. We want to solve this equal to 0, and I'm going to factor. And so I factor, what I'm looking for is this number here means I have to have factors which end up multiplying to be 10. And with this, I need x values that end up getting to be 3x. And so what I do is I just hunt and peck for a little bit, like I would try something like this. I know that the x coordinates have to be x and 3x. And then what I just do is by trial and error, I plug in numbers. And so eventually I'm going to get to this right here. And I multiply it out and I get 3x squared minus 6x plus 5x, minus 5x plus 6x minus 10. And so that's equal to that. So that's a quick review of factoring. Anyway, so once I factor, I want to set each of these equal to 0. So here's the first one. I add 5 to each side and divide by 3. I'm doing everything at once. So first I get that, and then I get 3x equals 5, and then I divide by 3. And I get x equals 5/3. Okay, for the second one, I just subtract 2 from each side. I get x equals minus 2. So my answers are x equal 5 and x equal 2. Okay, so let's go to the next one. Now again, we want to figure out, I'm sorry, let's go back here. I just wanted to show you on the graph. You see that when the graph crosses the x-axis here at minus 2, which is what this tells us. And then notice here, I don't need that. turn that off. This goes over to here. And I also cross at x equals 5/3 right here. Okay, so now we go on to the next. I want to find the zeros of 10 minus x cubed, so I solve this equal to 0. Now the algebra that I do here, I dropped the square roots, but here's why I can do it. I can square both sides because I'm doing the same thing to each side. 0 squared is 0. If I square the square root, those cancel, and I just get 10 minus x squared equals 5. So what I do is I add x squared to each side. This cancels. So I'm left with 10 equals x squared. To solve this, I take the square root of each side, and I do the plus or minus over here. Square root of x squared is x. Square root of 10 is plus or minus 10. So that's my answers. Here's the graph. And notice that if I go below here, if I take values over here or over here for x, I am going to get a negative number in here, which I just can't have. That's why the graph only has this little bit right here. It's the upper half of the circle. Okay, so I want to find the zeros of this. Now, when you have a fraction, what's going on the bottom does not affect whether the function's equal to 0 or not. So I'm going to multiply both sides times t minus 5 to get rid of the fraction. 0 times t minus 5 is 0. T plus 5. Excuse me. T plus 5 times t plus 5 cancels, and I'm left with t2 minus 3. I add 3 to each side. Then I get 2t equals 3. Then I'm going to divide each side by 2, And then I get, for my answer, I get t is equal to 3/2. And again, if you see a partial graph of the function, it does in fact cross the t-axis when that happens. Okay.